Okay, so this is the derivative lab. And there are some goals here. And you are, actually, this class is further short than I think than the other one. We want to develop the definition of a derivative. That's my first goal. To define the slope of a function by zooming in repeatedly. So if I have a curve like that, and I keep zooming in on this particular point, what's that curve going to look like? Straight line. And you can find the slope of a straight line. They're going to be so close together, the 2 points that you choose here. You want them really close together. It's almost the same as taking the slope at a single point, which is actually how your car works, but we'll talk about that later. We're going to define the slope of a function numerically by using n-derive on our graphing calculator. And I'm not sure everybody has seen that. And define the slope of a function algebraically using symbols. So there are 3 approaches for each problem that we're going to do. We're going to do the geometrical one, which is this zooming in idea. And then picking 2 points on the curve, and calculating the slope between those two. We're going to do it numerically, but we're going to let the calculator do it. It's basically the same as the zooming in. And that's that n-derive. And your syntax for n-derive, let's get that in right now. And I'll show you, we'll go through it on the calculator, but it's going to be your function first. And then we're talking about how does the y value change as the x value changes. So it's a change in y over change in x, where you have to tell the calculator what the variable is that you're looking at. It doesn't have to be x. You could talk about your change in your position as the time changes. Anybody recognize change in position over change in time? Is your, well, it's the change in the distance over your change in time. How many drive cars? It's speed. Okay, it's your velocity. Okay, so you can talk about how does your distance change as time changes. So you have to tell the calculator, how is my y value going to change as something else changes? So you don't have to totally understand that at this point. You will, hopefully, when you leave this class. But you have to tell it what the variable is that we're comparing the change in the y to. We're going to look at the change in the y over the change in x. So you have to tell it that, especially when you get to the Inspire calculator, the CAST, which will do all of these in any variable you want. And then you have to say, well, where do we want to find this? This is my point. Call it A, call it C, I don't really care. I want to find the slope at a particular point. Okay, that's just the summary. The lab, you learned in geometry that the slope of a non-vertical line is change in y over change in x. Okay. So this is nothing new. So slope is the change in y over the change in x. It's called a rate. A rate is a comparison of 2 things, miles per hour. It's a rate. You got to know that word, a rate of change, because that's all we're going to talk about, our rates per semester. So it's a rate of change. So it's how 2 changes compare, basically is what I'm doing here. And that's what the slope is. So we know that. Nothing new here. And it says, most functions we see in calculus have the property that if we pick a point on the graph of the function and zoom in, we will see a straight line. 1. Consider the figure below. Using the graph, find the slope of the secant. Now this is called a secant. So I drew this with my Inspire because the graphs are so much nicer. And when you take a line and you pass that through the curve like that, that's called a secant line. You got to know that. Remember in circles? Remember what this was called? Remember what that was called? It was called a chord. Remember that? And then in circles, we had these lines that came through like that, that cut the circle in 2 places. It was called a secant. We had some theorems about secants and tangents. Remember tangents? Tangents would intersect in just 1 point. and that's the tangent line. So secant hits the curve in 2, a tangent hits the curve in 1, in its neighborhood, wherever we are here. And a tangent line will only hit a circle once, not so true about curves. Okay, there's my secant line. And so here is, and I apologize if that's right on the axis, but we'll call that A. What's that ordered pair? If this is f of x, then what is the y value there? Not y. It's f of a. Oh, and we're going to do this over and over again. And then we're going to go some distance. Call that h. So I'm going to take h and I'm going to add it to a. I'm going to be at a plus h. That makes sense now? And what's this ordered pair? A plus h and f of a plus h. Your job in question 1 is to find the slope. Okay, any problems with that? I don't want to do it for you. Okay, so we will come back to that. Turn the page. I'm sorry there's misnumbering on this. I should fix that. Question 2, geometric slope. You are going to zoom in, and some of you have already done that. The notation for question 2 is this f prime. F prime of x means the slope at x. So if we're looking at f prime of 1, it is the slope at x equals 1. And we could put that on our calculator. There's ways to do that on our calculator and have it look at that. So you could actually draw it in there if you wanted to. So as you zoomed in, and one of the points to find your slope will be 1, -2, and then the other one, you have to make sure that when you zoom in on that curve, it looks like a straight line. You have to zoom in several times to get that to happen. And pick another point, start at 1, -2, just trace, and it's going to be 1.000, and you need to keep all those decimal points, all those decimal places. And that's true in the AP exam. Keep all the decimal places throughout your problems until the very end. Never hurts you to keep them all. It always hurts you to round or truncate until the very last minute. So keep those, and you should find a slope. And my guess is, what did you come up with? Those of you who did this. -2.9. Give me all the places that you see in your calculator. Okay, it's the only way I know. It'll be different for different people. Depends, right. Your group will be different than their group, but it should be 2.99 something. So it looks like it's getting close to -3. That's a limit. What am I going to do with this? I'm going to take this little point here, and I'm going to take this and I'm going to drag this, and what's happening to h? It's getting smaller. In fact, what's h going for? What's h going to be at the very end? No, h is the distance between these 2 points. So it's going to 0. It's called a limit. We've been doing limits to look familiar. Matter of fact, what you see here should look very familiar with what we've been doing. Okay, so question 3 is doing this by zooming in. That's all that is. And then on question 4, which is 3, sorry about that, you're actually going to fill in that table. If you want me to check the table, I can. And you find that the slope between, this is 4, which is really should be 3a. Sorry, my mistake. But the ordered pair is 1, -2. And then for the very first one, it's 1.6, because it says x equals 1 plus h. H is 0.6. And then it's f of that, whatever that is. I don't know what that is. And if you want me to, I can take the calculator out and show you how to do that quickly and easily, very nicely. Now, when you do a lab report, you should give one sample calculation. Like I would show this one. Then the rest, just fill in your table. Because who cares? They're all done the same way. And that's how you do things when you write up a report, because you want somebody to be able to duplicate what you've done. So you only give them one example. You don't have to give it all to them. Okay, and as h gets smaller and smaller, what's happening to my tangent line? Not my secant line, excuse me. As this point gets closer and closer, what's happening to the line there? It's getting closer and closer to the what? So the tangent line. Let's see. Do I have a color here? Well, let's make it now. It's getting closer and closer to this one, which is the tangent line. I just gave you another answer. It's there. Okay, so you're going to do the geometric slope. Then you're going to do the analytic one. And do you want help with this? Or did you do it already? This is f of x. This is the analytic piece. I'll let you answer the other questions, and you get a point for each right answer. By the way, so it's up to 32 points. It counts in the test category. It's our last major assessment. We'll have a quiz before the end of the quarter, but I think that's as far as we get, especially with this little delay that we're having. So it's your last chance to change your quarter grade. Now, what happens second quarter is you don't get a whole new grade. You don't start all over. You just keep going. And we figured out this was to your benefit. That, let's say first quarter was really hard, the second quarter gets easier, whatever. It balances everything out much better. Okay, so what I want to do is algebraically find the slope of the tangent line at x equals 1. So I have this graph. It does this, something like that. And x equals 1. That's 1, negative 2. And I have another point here. Not sure what it is, but it's going to be, I'm going to go over to the right just a little bit. We'll call that distance h. So this is going to be what? If I start at 1 and I go over h spaces, I'm at 1 plus h. Then what's the y value? It's f of 1 plus h. So what's the slope going to be? You know this. The slope is going to be f of 1 plus h minus f of 1 all over, well, I'm going to actually show it out. It's 1 plus h minus 1. You see slope there? What happens to the ones? They go away. So my slope is going to be equal to f of 1 plus h minus f of 1 all over h. Now that's the secant. What happens as I drag that point, wherever that is, at 1 plus h? I think that'll work. Find out in about 2 seconds. What happens to h? It goes to 0. And then I'll actually find the slope of the tangent line, the limit of it. It is a limit. So I'm going to find the limit as h goes to 0, and this is the part algebraically you might need some help with. It's f of 1 plus h minus f of 1 all over h. That should look familiar. We've seen that how many times in our limits and stuff? Do you remember? Because I'm going to do the tangent line at this particular place right here, at 1, negative 2. F of 1 is negative 2, isn't it? Because what's f of x? Sure. I'm going to do that in about 3 seconds. I'm just getting set up. Where are you looking? Right, but you want to do it at f prime of a. You already answered the question on the very first page. Except you're going to take a limit. Remember this one? You're going to let h do what on the very first page? Go to 0. So all you have to do is take what you got on the very first page and add in a limit. Now, do you need some help with the algebra on this? Yes. If you got it, great. You go on and work. We're going to go ahead and do this. Okay, so I'm going to rewrite f of x here in front of me so I can see it. F of x is equal to, because you're going to have to do a quartic. So it's the limit as h goes to 0. And I'm going to substitute in 1 plus h for my x. So it's 1 plus h cubed minus 6 times 1 plus h plus 3. That is f of 1 plus h. And then it's going to be minus f of 1. And Tori says, well, can't I just put in negative 2? Sure. It is. Now, you could go ahead and put in 1 here, and you'll still see you get negative 2, right? There you go, right? And it's all over what? It's all over what? And what I like about math, and I think some of you haven't realized, is it tells me what to do. I'm stuck. I got to take the limit. If I put h equal to 0 in there, I'm going to get what? What happens when I put h equal to 0 in there? I get 0 divided by 0. Okay, so that doesn't work. But there's another path. What do you think? You have no idea what to do. What do you think you should do with the 1 plus h cubed? Not factor it. Other way. Cube it. Multiply it out. And then after I get it multiplied out, I probably will add everything together and simplify it. And then a miracle will occur. Now, if you forgot how to do the cubing, let's go ahead and refresh your memories. This is Pascal's triangle. And if I have a plus b to the 0, I just get 1. If I get a plus b to the first power, I get 1a plus 1b. So the coefficients are 1, 1, and 1. And if I do a plus b squared, I get 1a squared plus 2ab plus 1b squared. And the coefficients are, remember what coefficients are, right? They're the numbers that precede the letters. 1, 2, 1. So when I do a plus b cubed, I don't have to do any work. Now, if you have a CAS calculator, and I have them in here, it'll do it for us anyway. And what's this going to be? What are the coefficients going to be? 1, 3, 3, 1. So I'm going to get 1. Now, notice it's a squared, it'll be a cubed, and then the a's are going to go down in powers, and the b's are going to start going up. There aren't any b's there, that's supposed to be to the 0. So it's a squared, and it's b to the first. These have to add up to 3. You're learning the binomial theorem on this process, which might pay off later on. Not just my class, future classes. And then the a's go down, and then the b's go up. And then 1b cubed. And I'm going to put a line through here. So when you do the quartic one, you're going to get 1, 4. Remember, you just add these. 6, 4, 1. And if you were to fill out a whole Pascal's triangle with lots and lots of numbers and colored in, say, all the evens, or all the odds, or all the multiples of 3, or multiples of 5, it doesn't really matter. You always get Pascal's triangle. You know what Pascal's triangle is, right? This thing, you keep cutting out the middle third. That to me is absolutely amazing. And you keep cutting pieces out. And you end up getting 0 area and an infinite perimeter. And that's what chaos theory is all about. I have a mess, but no. Okay, so do I need to help you simplify that, or can you guys do that? I can help if you want. Let me go through it with you. But just do what it says. Okay, let's see if I can copy this. Okay. Okay, so we just have to do this. Whoops. So what's 1 plus h cubed? Okay, it's the limit. And by the way, please don't be lazy. You need to keep the limit. It's like saying 2 plus 3 and dropping out the adding sign. Doesn't make any sense. It's 1 plus, what's the coefficient going to be? In fact, if you want me to write it all out, it's 1 cubed h to the 0 plus, what's the next coefficient? 3, 1 squared, which I want to write, but anyway, h plus 3, 1 to the first power, h squared, plus 1, 1 to the 0 power times h cubed. Because that's how you multiply 1 plus h cubed out. It's this one. I'm just writing out all the stuff. I'm going to write it set over there because I ran out of space. So I'm going to clean it up. I'm just cubing 1 plus h. Remember, I gave you a plus b cubed. This is 1. This is h. Just substitute it in the formula. That's all there is. So it's 1 plus 3h plus 3h squared plus h cubed. That's what 1 plus h cubed is. Now I'm going to follow my little rule here. Oh, I got to do this. Now, having done all this work, I almost forgot about this, the rest of this expression up here. But it's minus 6 minus h plus 3. That's the first parentheses that I have in blue. Oh, I made a mistake. You're right, minus 6h. Don't do that right. And it wouldn't work otherwise. Okay, oh, and then the hard part, what's this going to be? Minus 2 is plus 2, and it's all over h. And I have promised you, I don't make promises I can't keep. At least I try not to. But unless I've made a mistake, I might have made a mistake. But I promise you, if you do this right, you will always cancel out that 2 over there. Always. So it's the limit as h goes to 0. So it's 1 plus 3h. Can't do anything with the first parentheses. And then it's minus 6 plus 3, so it's minus 3 minus 6h plus 2. All over h. And it still tells me what to do, because I know what to do with that. If I add that together, what happens when I add the 1 and the minus 3 and the plus 2? Go away, right? Boom. I promised. Anything else I can combine? I can combine a 3h and a minus 6h, right? Which gives you what? That's where I would have had a problem. But minus 3h plus 3h squared plus h cubed all over h. Now, I prefer to divide that out, but you guys prefer to factor it, so we're going to factor. As long as I divide h into everything, it's fair. So it's minus 3 plus 3h plus h squared all over h. And what happens to the h's? Because that was the 0. Remember 0 over 0? It's always that whole. That's my 0 problem. Now for the calculus. None of that was calculus. All of that was algebra. The calculus is to plug in h equal to 0, and what's the answer? H is 0. What's going to happen to these little terms here? Negative 3. Which is what you had guessed, right? Based on the first thing by zooming. And let's go ahead and do n derived, too. Take me a second to get my calculator up here. Especially when I don't know where it is. There it is. Okay, so that's the analytic piece. Okay, so you've done the geometric. We just did the algebraic, the analytic piece, and now, and I gave you directions here, but we're going to actually go through it. Yeah. Well, at 1, you have to make a guess as to what the limiting value is. You're right, it's not that. It's all geometric to guess what the limiting value is. Okay, so guess what I got to do? I've got to put in, why is my calculator the wrong color? Okay, got to put in my function, which was x cubed, and it automatically goes to pretty print, so I have to remember that. And it's minus 6x. What was the rest of it? Okay, no. Plus 3? Okay. I'll show you a couple things here. I always zoom it in a decimal window because when I trace it, it's nice. And, you know, I can fix this so I can see those if I want. I can change my window. Now, it won't affect it. The X's are what affects the pixels there. So make it negative 10. I don't know if that's going to be any better. There, that looks nice. Okay. So there's a couple ways to do it. If you have your graph on the screen, you can do it this way. Okay, guys? you can go second, calculate. You're going to know what all these buttons mean. We can do 6. Now, dy over dx looks like delta y over delta x. It is, as long as h goes to 0. That's what dy dx is. It's a new symbol. So it's 6. And I want to do this at 1. But you have to have the right window. And there it is. Negative 2.9999, which is what you found by zooming in. So this is the numerical piece. So this was second, calculate, and it was dy over dx. That's the slope. There's a lot of different things we can do. That's 1. So when you do this, you'll know this eventually. Right now, not yet, but you will. There's another way to do it, and since we're in the graphing screen, I'd like to draw the tangent line. I can do that. But you never did draw before, did you? So see, draw is right above program. So press the blue second key and the draw. And we want a tangent line, which is 5. And we want to do it at 1. And my cursor's at 1, but let's pretend it's not. So I'll press 1. And I press enter. Nice. There it is. I can do it again. And you guys know how to read equations and lines. What is the slope of this line? Right there. Slope is negative 2.9999. Whatever. So I'll do that again if you would like. Should we do it at a different point? Because you can. Second, draw. And I want a tangent line. I can do a vertical line, all those things, 5. I want a tangent line. And should we do this at, well, let's do it at 2. And there it is. So it draws your tangent line. Now, the nice thing about the Inspire is you get it in color. Okay, the only problem with the downside of doing this on your graphing calculator screen, and yes, you need a calculator to do this, but the downside of this is that you have to have the right window. So let's say I don't have the right window. Let's say I don't know what the window's supposed to be. And I just want to find a derivative. That's what this is called. It's called a derivative. So I'm going to quit. And I can do this by going to the math menu. Now, most of you are probably 83s. Some of you have 84s. They can't be upgraded. Any 84 can be upgraded, I believe, but the 83s can't. So we're going to do it the old-fashioned way, and then I'll show you the new way. Math. And it's going to look a little different for you. This little arrow here by the 7 means that that there's more to come. Whoops. And you don't have all these things, but you should have in 8 and derive. Do you have that? So press enter. Now it's not going to look the way it does on an 83. This is actually going to be in pretty print. And then I have to say it with what variable. So if you have a new one, you're seeing this. So you have to say that's an x. We'll learn what that means in a second. Actually, this is the time of year when I wish I didn't have the pretty print. And this is my function. Now, I don't want to type in x cubed minus 6x plus 3. I don't want to do that. I can pull it out. It's in y1, so I'm going to go vars. And we're never going to do any of this other stuff. We're going to go to y variables. Unless you're going to program, you don't need any of that. We're not going to do anything with parametrics or polars or any of that stuff either, so it's going to be a function. Should have learned this last year. And y1. And then I have to arrow over and tell it what point I want to find the slope at. That's what it's asking me for. And I want to do it at 1. And there it is. Now I'm going to take this picture and I'm going to write out what you see on an 83. This is not what you see on an 83. TI-83s, you will be doing n derive, which is still math, 8, right? And then you're going to put in y1, just the way I did it. Then you're going to put in an x, and then you're going to put in a 1. And yes, we'll be quizzing you on this. You have to be able to do this. 4 things you have to be able to do in your calculator. This is one of them. N derive. And it's this dy dx thing is just find the slope. That's what that means. It's the slope of y1. Yes, Sam. There's no showing except that you will give me all the decimals. The only way for me to know. So if you give me -3, then I know you didn't do it. Because the calculator is not going to give you -3. Unless you're on Inspire. Do you have any Inspires in here? Might look at that real briefly. Okay. Oh, let's say you have an 84. I want to do the same thing again. I'm going to clear my screen. Now, there are shortcuts. They actually made these function keys work. There are shortcuts. If I go alpha, and I want the derivative, I think it's in this one. No, it's in this one. Zoom. Nope. There it is. 3. There's a little shortcut. And then I can do x. You always have to say x in the denominator there. And then I want to get y1. There's a shortcut for that too. Alpha, and I go to trace, and there's the y1. It doesn't matter. It just does speed things up. So before the exam, you might want to get that if you have an 84. Make sure you get upgraded. And this is at 1. So it's done the same way. It's just faster to get those keystrokes. And once I upgraded mine, I can't go back to the old book. So I have to actually verbally tell you what to do there. Now you had another question for, oh, we'll finish with the Inspire because I'm not quite sure what it's going to do. We're almost done, actually, in terms of what I have to do. And then that's the analytic slope. 5 is using your calculator. And I write down everything you're going to see there. It's all there. And we now have an analytic definition corresponding to the geometric picture of the derivative of a function at a point. It is an important aspect of calculus that there is an algorithm for computing the derivatives of familiar functions. Not surprisingly, your calculator has a command to give you values for the derivative f prime of a. For problem 6, the directions are for the following 2 functions, you will need to investigate it using all 3 methods. 1 is the geometric by zooming. 2 is the analytic. That's actually calculating the limit by hand. And 3 is using n-derive. And you're going to do that for the following 2 functions. I'm just going to write them up here. So you're going to do this for a and b. A is f of x equals x to the 4th minus x squared plus 3. And you're going to do this at the point 1, 3. And b is at the sine of x at pi 0. Do you have to do those little h's in that little table that we have over here in these pictures? No. Just follow the directions. So you're going to do all 3 things that we did for the first function for those 2. You're going to need Pascal's triangle to do x to the 4th. So you're going to put in 1 plus h to the 4th. And then what are you going to do with this? Now you should have seen the sign of x plus y last year in pre-calc. This is equal to, there's an identity. It's the sine of x, cosine of y. I believe I got this right. Plus, otherwise I'll look it up. And it's the cosine of x times the sine of y. You should have seen that identity. The reason for it was, if I wanted to find the sine of 75 degrees, I could think of that as the sine of 30 degrees plus 45. And then I could use this identity because these are special triangles. And that was because we didn't have calculators. Well, today we do have calculators. And now I need some of this stuff when I do some stuff with calculus in terms of changing things around. But for our class, we really don't need to know that anymore because we have calculators. I would just punch that in my calculator. So in my day and age, we had to do this using those identities. But I always looked them up when I needed them. So it wasn't like it was a big deal. I'm not sure where my math VOC tables are. That's a big, thick book like that. You looked everything up. Okay, and then number 7, you are going to investigate by graphing that function on A, and there's a function on B, and you're going to see what you think about what happens. There's some special problems there. And then don't forget to answer question 8. It's worth a few points. And it's not complicated, so don't make it hard. And then instructions for your report. 4 students per group. Include all the names on the top page. If you do not include a name, I will assume that 4th person did not participate. You turn in 1 report per group. The report should be written on a new piece of paper. It can be handwritten, that's fine, just make it neat, that's all. You may cut the graphs from this handout and paste them right onto your report. Your report should be clearly written and put together just like you would a formal lab in science class. You should use complete sentences. You should include a sample calculation for each major calculation, like finding the slopes at 1 plus h. And if you do not follow these directions, your report will return to you to make corrections. Okay, so it's pretty clear, I think, in terms of what's expected. And I'll be here Thursday morning and Friday morning. You have today's class. Tomorrow I'm not going to say a word. You have all of tomorrow to work on it together as well. And this is a joint project. This is not, oh, you're going to do 2A and B, you're going to do 2C and D, and you're just going to kind of paste it together. No, no, no. Make it work better than that. I mean, I've seen scraps of paper coming in. That's not okay. Okay. Anything when you write something up, if it'll ask you a question, use a complete sentence. I'm not going to grade you on grammar, but you should be careful with grammar. Okay, so I did a lot of this. And it probably should